Now that you've learned about when and how to use the product rule, you might be wondering why it works. H of x, that is the product of two other functions, f of x and a g of x. Before you learned about the product rule, if you had seen something like this and you were asked to compute the derivative function h prime of x, your instinct would be to compute the derivative of f and then the derivative of g and then multiply these derivatives. But, as you learned, this wouldn't be correct. The question now is, why does the product rule work? Why do you need to use the product rule instead of just doing what seems intuitive? Let's look at what's happening a little differently. I'm going to think about this in terms of area. So I'll represent f of x as the length of one side of a rectangle, and I'll represent g of x as the length of the other side of the rectangle. So now, h of x represents the area of this rectangle. And then, h prime of x represents how quickly the area of the rectangle changes as we change the value of x. Now, if we increase x by a tiny amount, then f of x will also change by a tiny amount. In the past, we've called this delta f. And when the change in x is small enough, we write it as df. Similarly, as we increase x by a tiny amount, then g of x will also change by a tiny amount, and we'll write this as dg. Next, let's think about what happens to the area as we increase x by a tiny amount. As x increases, f of x changes by df, and this changes the area of the rectangle. Similarly, g of x changes by dg, and this also changes the area of the rectangle. You might also be wondering about this tiny green rectangle. Since it's part of the area of h of x, the key here is that, unlike the purple rectangles, when delta f and delta g become df and dg, then the green rectangle has both of its dimensions that are infinitesimally small. So it doesn't actually contribute enough to the area of the big rectangle, and we're going to just disregard it for the rest of our computations. Next, we can think about how much the area changed by. As x increases, then the area changes by delta h. And if the change in x is small enough, then we call this dh. The area that we got from the change in f is df times g of x, and the area that we got from the change in g is dg times f of x. So the total change in area would be the sum of these two areas. And if we remember that the derivative of h is dh dx, then we can divide each side of the equation by dx, and then do some algebra, and a little more algebra, and then we have dh dx, dg dx, and df dx, which are each derivatives. So we can rewrite this as the derivative of h of x is equal to the derivative of g of x times f of x plus the derivative of f of x times g of x. So this is where the product rule comes from, and why you need to use it, because f and g interact with each other when finding the rate of change of their product.